Okay, welcome back, guys. We're in the second video of this course, and last time we talked about functions and we talked about inputs and outputs and independent variables and dependent variables. And now we're going to talk about evaluating functions. Remember, for it to be a function, one input produces one output. So anyway, we'll continue on with evaluating functions, but first I wanted to cover notation. So I've got it up here written in the corner. So y is our output, x is our input, and those variables can change, but the way you would read this is y is equals in math, like math to English, equals means is. So y is a function of x is how you'd read that. And it doesn't always have to be f. F is the commonly used variable to name the function, but all f is the function name. Lots of times you see g or h used as well, but you can use, whatever variable you would like. So same with your input and output variables. So y is our output, f of x, that whole expression, or that whole, I don't know what you want to call it, but anyway, f of x as a whole is also the output, which is why they're equal to each other. So you can write it either way. F of x is nice because then you know what your input was, because that's where your input will go, and then you have your output paired with your input, and we'll see that here in a minute. So just so you know, y is an output, f or whatever letter is here is just the name of the function, and x is the input. So now we'll go ahead and move on. So here we've got our function g, whereas over there it was function f. This one's function g, but it's also written in terms of x. So x is our input. Now, it's easy to get confused on where to plug things in or make algebra errors. So the easiest way to evaluate functions is find your input variable, which in this case is x, and rewrite the whole function with x replaced, or whatever variable you're using, replace it with parentheses. So we'll do that now. So we leave the gap, keep it with, or leave those parentheses. Now I've got an x here, so we'll put parentheses instead, squared. So whatever we plug into the parentheses will be squared. Plus 2, we have another x here, so here and here. We'll replace that with parentheses minus 1. So now when we evaluate our function at these various inputs, we'll know exactly where they need to go because we have parentheses there telling us where to put them. Okay, so for g of 4, we find all the parentheses and we just plug in 4. So we're using functions g and our input is 4, and then we have our function here with our inputs plugged in, and then you just evaluate, you just solve. So we've got 3 times 4 squared, which is 16, plus 2 times 4 is 8. We'll just write that. Minus 1. And then you just keep solving. So 3 times 16, I believe, is 48, plus 8 minus 1. And so 48 plus 8 is 56, minus 1 is 55. So parentheses make it super easy, and it'll get a little more complex, especially when you start plugging in expressions. So let's keep going. Now we can just replace our input. That is 55. So now moving on, we'll plug in our input, which is now b. Plug it into our parentheses. And now we just evaluate again. So we've got 3, and then we have b squared plus 2b minus 1. And there's your function in terms of your input. And then you'd write, so here you see what your input is, and you see what your output is, all in the same line, which can be helpful so you remember what you plugged in to get your answer. Like we plugged in 4 to get 55 using function g. So this notation is pretty handy. It's good to know how to use it. So now I'm going to erase this whole thing again, and we're going to practice writing our parentheses with this expression inside, because it's super important that the x and the 7 stay together with their plus sign. We don't want those to get separated. So rewriting this function, our input variable is x. So we'll replace those with parentheses like that. 3 times, we've got an x there, so parentheses. And those parentheses are squared, plus we have another x there, 2 times parentheses minus 1. Yikes, that. Okay. Anyway, so now our input is x plus 7. And we've got our parentheses written out, so we just plug in x plus 7. And I'll do that with green. Plug in x plus 7, x plus 7, x plus 7. And because we wrote these parentheses, like with this square here, we know exactly what's being squared. We're not confused. Had we not written parentheses, it would look something like this. And that is really confusing. You're not sure, is it 3 times x plus 7 squared? You know, so make sure you write your parentheses so you're not confusing yourself when it comes to the algebra. So then we just continue solving. And a way I was taught to multiply binomials, this is a binomial, bi meaning 2, so you've got 2 parts, and it's a polynomial with 2 parts, so it's called a binomial. I was taught the FOIL method, and FOIL stands for first, outer, inner, last. Meaning, those are the portions that you multiply together. So I'll show you what I mean. We have x plus 7 times x plus 7 squared plus. So starting with first, this means the first part of the binomial. So we multiply these two together. So x times x is x squared. And then we go to the outer terms. So x is on the outside and 7 is on the outside. So we go x times 7, which gives us 7x. And then we go to the inner terms, which are 7 times x plus 7x. And then you go to the last terms, which is 7 and 7. So those get multiplied. And this is a good, easy way of just making sure that every part of the binomial gets multiplied by the other part of the binomial. As you can see, x is being multiplied by both parts, and so is 7. So that's been super helpful for me. I hope it helps you too. Carrying on, we go here, and we've got to do some distribution. So 2 times x is 2x, and then we go 2 times 7 is 14 minus 1. So we've got this huge long expression, which came from evaluating function g at x plus 7. And then you just keep on solving. So we've got this big beast here, and we've got to distribute our 3 through. So we've got 3x squared. We can combine these terms, so we get 14x. And then 3 times 14 is 42. So we get 42x. Erase that. So we got those taken care of. And then 3 times 49 is 147. Plus 2x plus 14 minus 1, that'll be plus 13. We can combine those. So we've almost combined all of our terms. I kind of started doing that as we went. Go ahead and watch it back again if I skipped a step or confused you there. But yeah, I just started combining like terms. So we can continue to do that. We've got an x squared, no other x squareds, but we do have an x term and another x term, so we can combine those. And then we have a number and another number, so we can combine those as well. So our final expression is 3x squared plus 44x plus 147 plus 13, which is 160. And so this is our function. So that is evaluating functions algebraically, meaning doing it with algebra. You've got a written equation, and you plug it in and chug it out. Plug and chug. So we can also rewrite functions in terms of certain variables. So for example, here we have this equation or this formula, and we can rewrite it as p is a function of n. so we can write it in terms of n, where p is on one side and n is on the other side, or p is by itself. We can also write it where n is by itself. So we'll practice doing both of those and just doing a little bit of algebra. So if we want p by itself, we've got to get 3n to the other side, and we can do that through subtraction. So I'll go 3n plus 6p equals 15. So we can subtract 3n, and that'll give us 0 on this side, but we've got to do it to the same side to keep the equation equal, minus 3n. So we have 6p equals 15 minus 3n, and then we can just divide by 6, and we've got to do it to every term to keep that equation equal. And so this 6 divided by 6 is just 1, so we're left with 1p, which is what we like to see. That's what we want to do. We've got p equals, and then 15 divided by 6, that can be simplified. They both have a common factor of 3, so we can factor out that 3 and cancel it. So that would be 3 times 5 over 3 times 2, right? 15 over 6. And these 3's divided give us 1. So we've got 5 over 2. Write that here. Minus 3n over 6. Well, we've got a 3 here. And this is 3 times 2. So the 3's cancel to give us that 1. So we have n over 2. So now we have a function p where p is by itself. And on the other side, we have the function written in terms of n. So these are the same. It's just p is now a function of n. And we can do the same thing, but opposite, where n is a function of p. And our function's name is just g for this case. So let's go ahead and do this one, where we write this formula in terms of p. So we want n by itself. Okay, so to get n by itself, we need to subtract this term over, minus 6p, do it to both sides. That gives us 0 here, so those cancel out. Now we have 3n equals 15 minus 6p. Now to get n by itself, we just divide by 3, because that'll give us 1. And then we divide by 3 on the other terms to keep it equal. And we're left with n equals 15 divided by 3 is 5. Minus, and then we have 3, and 6 is also 3 times 2. So these 3's can cancel, and we're left with 2 times p here, minus 2p. So now we have a function where n is the output, p is the input, n is a function of p. It's essentially what we did. It's just some algebra, being able to rewrite equations and functions as you need. But the problem, or something you want to be wary of, is if you do rewrite the equation, it may not be a function. So you might recognize these squares and how they were a problem in the last video because of when you rearrange it. Let's go ahead and rewrite it where y is a function of x. So we want y by itself. So we have y here. We want to get it by itself. First thing that we can do is just subtract x squared from both sides. These subtract and give us 0. Now we have y squared equals 6 minus x squared. So now we want to square root both sides. And remember from the last video, if you're the one to draw the square root, then you need to be the one to draw the plus or minus. So we've got our plus or minus here. We'll rewrite this. So y squared square rooted is y. And that's equal to plus or minus the square root of 6 minus x squared. So we rewrote the function in terms of x, but it's no longer a function anymore because we've got this plus or minus. That was the issue that we went over last video, that this will give you 2 outputs. No matter what number we plug in for x, we're always going to get a positive version and a negative version of the solution, and that's 2 outputs. So this is not a function. So just be wary of that when you are rearranging equations. So now we'll evaluate tables and graphs. So we did it with algebraic functions, or we did it with equations and stuff. So now we can do it with tables too. So here we've got a table where t is our time, and that's our input in this case. And then we have distance, which is a function of t. So we've got our inputs here and our outputs are here. So for example, if we need to find our function d evaluated at 5, which is our input, we go to our inputs and we look for 5 seconds, and we have 5 seconds right here. Well, the corresponding output is right next to it, and that's the nice thing about tables is the inputs are paired with their output already. Makes it really easy to find. So our answer is 13 feet. If we throw a ball and it's in the air for 5 seconds, let's say it goes only 13 feet. Anyway, not realistic, but for this case, that's what happened. And we can do the reverse as well. Let's say our output is 33 feet. Well, how long did it take for this ball to travel 33 feet? Okay, well, we find our distance and we look for 33 feet, and we find it right here, and the corresponding input is just right next to it. So it takes 15 seconds to go 33 feet. So maybe you're rolling it instead of throwing it. I don't know. Anyway, so tables are super easy to evaluate. You just find the input, and next to it is its matching output, and vice versa. Now, it's also pretty easy to tell if it's a function or not. So we've got our inputs here and our outputs here. We've got one input for one output, one input for one output. So this one is a function because every input has an output. Well, here, okay, we've got one input has an output, same thing here, same thing here. Now we have similar outputs, but that's okay. It's okay for separate inputs to have the same output. If you remember from the last video, we could plug in a red apple or a green apple, and both of them could give us apple juice. That's okay. Where problems arise is when we have the same input getting two different outputs, you know. Kind of like that plus or minus. Let's say this one was -4 here. If we plugged in 3 and we got +4 and -4, that's not a function, that's an issue. So we've got an input that has an output, but this here, I mean, yeah, you could write it like that, but still you have the same input getting two different outputs. This would be the same as writing it like this. 3 gives us -4, but it also gives us +4, and we don't want that. Or that's not a function. So this is not a function, but these two are. Now graphs are nice too because they're visually helpful as well, where you've got the x-axis, which is generally your inputs. So like here, we've got -3, 0, and 4. Those would all be on the x-axis. And then the y-axis is our outputs. So here, we've got our inputs, and y is our outputs, and we have our function right here. So this looks something like this. You know, y is a function of x is our input, y is our output. So f is our function. If we want to find f of 2, we go to our input line here, our input axis, and we go to 2. So we've got 0, 1, 2 here. So, well, what is our output? We're up 0. We didn't go up any in the y direction, so our answer is 0. Okay, well, what if our output, f of x, which is equal to y, if y is 2, we can find that on our output y-axis. So if we go up to 2 here, well, we didn't go very far in the right or the left direction. We stayed on the axis, so that is 0. So x equals 0. So that's how you evaluate graphs and tables. That's how you find the inputs and the outputs. And I hope that was helpful. We'll keep covering this as we go on, and we'll have some examples in a couple videos. And if you have any questions, comment them below. And thanks for watching.